here we are with another question from our hashing series. The problem is 202nd problem, that is happy number. The problem says write an algorithm to determine if a number n is happy. A happy number is a number defined by the following process. Starting with any positive integer, replace the number by the sum of the squares of its digits. Repeat the process until the number equals 1, where it will stay or it loops endlessly in a cycle which does not include 1. Those numbers for which this process ends in 1 are happy. Return true if n is a happy number and false if not. So to solve this problem, since we are doing hashing series, we'll be using HashSet. Let's visualize this problem through the examples. Let's go with this example first. So n is 19 and we need to split it into 2, that is 1 and 9, and add the sum of squares. So we get 82, and then we repeat the process until we get 1. So basically in the hash set we'll be storing these numbers, and during the process if we get 1, then we return the number is happy by returning true. The same way, if we look at the second example that we have, that is n is 2, when we loop through this number, 2 becomes 4, 4 becomes 16, 16 becomes 37, 37 becomes 58, and 89, 145, 42, 20, and 4. 4 is back. 4 is repeating. So this indicates that this number, that is 2, is not an happy number. So therefore, we use a hash set to remember every number we previously generated. If we reach 1 during the process, then it's a happy number. And if the loop continues and if any number is regenerated, then a cycle is detected and it's not happy. Moving on to the algorithm. Firstly, we will have to create an empty hash set. Continue while n is not 1. If n is already in the set, return false, as we saw in the case of 2. 4 was repeating, so as soon as we detect the number is repeated, we return false. And add n to the set. If it's not already present in the hash set, then we add it to the set. Calculate the sum of the square of the digits. So how do we do this? Talking about 0.5. Here, look at this. When n is 19, we basically extract each digit from the number from the end. So firstly, we'll have 9. So how do we extract the last digit from the number? That is through this formula. We get 9 and then we add 9's square to the sum. The same way we update number. Again the while loop runs and then we come across 1. 1 is added to sum and then the number becomes 0. The loop ends. Now we have to update n with the latest sum. That is how the algorithm works. Yeah, this is what. The sum is assigned back to n until the n becomes 1. If n becomes 1, then we return it as true. Now let's code this solution in our LeetCode. First of all, what are we supposed to do? We are supposed to create an empty hash set. Let's do it. Hash set integer set is equal to new hash set. Then according to the algorithm, we need to continue the while loop until n is not equal to 1. So how do we do it? While n not equal to 1, while loop is created. Now if n is already in the set, then we need to return it as false. If set dot contains n, then return false. Now we are done with checking if the set contains the number or not. Now the next step in our algorithm is add n to the set. If it doesn't contain, we need to add n to the set. Like this, set dot add n. Next step is calculating the sum of the square of its digits. That we do using a variable called sum, which we assign it to 0, and a while loop running until n is greater than or equal to 0. Here we will be finding the digits from the end from the number called n. So we calculated by n mod 10, and then we update the sum plus is equal to digit square, digit into digit, n divided by is equal to 10. This is basically updating the value of n, because you're using a while loop and every condition it loops, we need to update n. That's why we do that. Now we are done with the while loop, that is calculating the sum of the squares of the digit. Now we need to assign the sum block back to n, because our number has changed, right? See, if you look at this example over here, firstly we were given with 19. Now we have calculated 82. We need to update it back to the number n, so that we continue with the loop until we reach 1. So here n is equal to sum. What's the next step? If n becomes 1, then return true. So we are done with this while loop as well. Now we need to return true. Let's test all the cases. Oh, time limit exceeded. Where did we go wrong? I probably think it's from the while loop. Let's look into that. While n not equal to 1. This is correct, because until n is not equal to 1, we need to continue the loop. Next while loop, we have it over here. While n greater than or equal to 0. This should be greater than 0, because n can never go negative. It can become 0. So yeah, infinite loop condition we have given. Just look at that. I hope you guys understood why I removed that equal to sign. See, all our test cases are passed. Now let me submit this. Yes. So now let's talk about the complexity of this problem. So the time complexity of this problem is big O of log of n. That is because a number has approximately log 10 of n digits. So we process every digit using this to calculate the digit, each and every digit in the number, and this to update the value of n each time we find each of the digits from the number. So calculating the square sum takes big O of log of n time. So the time complexity becomes this. Now moving on to the space, the HashSet stores the generated numbers until we reach 1 or detect a cycle. The number of stored values is bounded relative to the number of digits. So we represent it as big O of n space. Thank you for watching this video. If you have any doubts regarding the problem that we have solved, please let me know in the comment section. Thank you again.